Hi folks, this is the 2015 question 4. So I have a good bit of the setup done here. So I've drew my elevation, and from our elevation then we've been asked to look in from the left hand side there. And if you're asked to look in from the left hand side, that means your elevation end view must go on the right hand side. I've divided it up from a 60-30. The inner circle, the cylindrical part been alphabetical, the outer part been numerical there. Okay, so that we have a cylinder here and we've part of a cut cone or a truncated cone there. Now, so there should be no real problems drawn most of this, okay? So what we're going to do is, I'm just going to drive on with this. I'm going to finish out the end view first of all, okay? So the end view will come up as far as there. You can go up as far as that there actually. Now, this point here, there's a portion missing, so it lands directly from me on I and J. So I bring them over, and I bring them up there. I'll get that. I get that there. Bring it across. Now, this is a cut cylinder here, okay? And anytime you get a cut like that, you're going to get an elliptical shape, not a parabolic shape, but an elliptical, shape. So, basically, we've our circle already divided up there, cylinder in plan view, okay? So I bring up these points. Now, you actually already have 3 points even before you start there. You have A, we have D at the top, and we have G over here on the outside, okay? Now, F and B are on this line, so if we run them out and they're going up, they're on the same line here, we can just extend up these guys actually. Now, F and B, if we take them there, take B for example, it comes up, where it hits here, it's going to come out. That'll get me B there. And F is on the opposing side. And then C and E, I'm going to bring them out there. They'll be somewhere on that line there. We go C, we go E, then we can run them up there. They give me C and they give me E there. And now we can do in this freehand curve, elliptical curve. Always keep D fairly flat. Okay, don't ever have a point on it. Bring it down the other side, and that's our elliptical curve. There's 2 little lines there we're missing actually. There. Now, that's that finished. Next thing you've been asked was for a surface development of B. Okay. Now, we already have a good few of the lines brought up here. So I'll just bring that up there. So if you want, that's J out there at the edge. The next point in is I and K. This point up here is H and L as I make it out. We have G and A here, there. F and B. E and C and D. And if you keep labeling, folks, if it goes together that way in plan, it has to go the same way later on when you're joining them up. A has to go to B to C, etc. and so on. Now, handy's probably way to do that would be to run it out here to the right hand side. Okay. Take out a light line like there, take out all our height lines. Now, you can start it anywhere you want. Usually we start it at the lowest point, which would be J there. Okay. So you can go any way you want after that then. Now, one thing you must do actually, we must step out, have 12 equal sections in this, okay? So if you get your compass, and take any one of these, this distance, we'll say from here to here. Set our compass to that. We can mark them out there. That's 1, 2, 3. Now it's just checking them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Lovely. Now we can run them up then after that. So if you start at J there, for example, let's take K next. So that's K up there, same height. After K you have L, L goes to another height. And actually we should label them in as we're going along as well. So we're going to have, it's an unusual one, we'll have a couple of even flat pieces, okay? So if we start off with J there, and it's coming into that is to J, okay? Then we're going up. Up there, coming in as far as A, and I'm going to do the same the far side. Heavy line there, and from here then we do our freehand curve in. And that's the surface development of B. Now A is different. A is a conical, is a cone, based on a cone, right? So what we've got to do is pretend that the cone was never cut. I'm just taking this purple coloring pencil now, we pretend it went down up like that. You're going to need two radiuses. You're going to need the big radius here, okay? And you're going to need a small radius. Let's get another color. I'll take this orange color. You're going to need the color from here to here. Or sorry, the orange color, which is the small radius from there to there. So anywhere at all, get your compass, set it to that. So we've got to pretend at the start like the cone was never cut. I'll just pick a point there on my page. I'm going to draw in this big arc. After that, what we need now is we need to take any one of these distances here. So if I take that distance there, set my compass to it, and I'm going to mark that off 12 equal distances. Now just check that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Lovely. Lightly drawing that back in there for the moment. Now the other radius you need is this guy, because he was chopped off. So set our compass there, back in the same spot, and swing in that there. Okay. So from here to here is the small radius, and from there to there was the distance of the big radius, okay? Now, so you're always going to have, if that's curved in plane, you're going to have a curved shape over here. You could do outer heavy lines a bit heavier than if you wanted to, okay? But remember your two radiuses. Always pretend as if the cone was not cut first of all. Get your true length, okay? That'd be your extreme generator, as we used to call it when we were talking about solids in contact. Swing that big radius, then you'll have to swing the radius that's been cut off, okay? And then all this shape in here, that's all the true development of surface A. So I hope you found that video, folks, useful. More to come. I'm going to be putting up some ordinary level as well as a few ordinary students have opted to take the ordinary paper in June. Okay, stay safe, folks, and remember, keep up the good work.